For the steps for dimensional analysis, first thing you want to do is to line up your starting and ending points. So figure out what you know and what you don't know in the problem. Next thing that you want to do is line up your units so that they cancel out, and then go backwards and fill in the numbers. So for these problems, what I mean by that is so that they cancel out. If you think about the number 4, divided by 4 is 1. Any number divided by itself is 1. So if I said pizza divided by pizza, that means pizza has now canceled out and become 1. So when we want our units to cancel out, then we just want 1 on the top and 1 on the bottom. And then there's this hint here that says leaving goes on the bottom, the place you're headed to goes on the top. What that means is if you are lining up units and you're starting in the normal first box, which you'll see in just a second, the place you're starting at goes on the top, goes on the bottom, and then wherever you want to get to next goes on the top. And that'll make some more sense as we go through. And then another hint is step number 3 is to multiply everything on the top, divide by everything on the bottom. And just something I want to point out here, if you type this number into your calculator, some of you will do it correctly, but many of you will do it wrong. And that's because your calculator is not very smart. So if you type into your calculator 2 divided by 4 times 6, which is how you would read this, then your calculator is going to take the number 2, divide it by 4, and then multiply that by 6. It's not going to take into account the fact that this 6 is on the bottom. So make sure that if you want to type this in, you either add parentheses in your calculator, or you type it as 2 divided by 4 divided by 6. That's a mistake that I see a lot of people make. And then the last step with this is we want to check our units and your answer. So, first thing, your parents get you a new car for your 16th birthday. If you were to get a new car for each 16th birthday, how many cars would you own after 62 birthdays? So what we want to look for here is our known and our unknown and identify those two things. Our unknown is always going to be the question. So in this case, our question is how many cars? And it's going to be how many, how much, how far, those kinds of questions. Our known is going to be a number, and sometimes ratios are going to be given to us in these problems as well. The other known is 62 birthdays, and there might be some other information in this problem that we need. So when I start these problems, I'm always going to start with the known that's given to me in the problem. So in this case, 62 birthdays. And that is step 1. I've identified my starting and ending points. Step 2 is to line up my units so they cancel out. So since I'm starting in this top section, the place I am at is going to go on the bottom. So I'm going to take birthdays and I'm going to copy it. Just the units, not the number. And then I am going to convert to get to cars. And cars is what I want my answer in. As long as there is a ratio that makes this true, then it's information that I can plug into my problem. So I need a ratio now that makes this true. If you go back and read the problem tells you you get a new car, that's one car, for each 16th birthday. So in my ratio down here, you get one car for every 16 birthdays. This has to be a ratio that is true. That is step 2. Step 3 is to multiply everything on top and divide by everything on the bottom. So the math that I'm doing is 62 times 1, and then divide that by 16. So multiply everything on top, divide by everything on the bottom, and then check your units and your answer. So I'm going to go back to my problem, and I'm going to make sure that everything canceled out. So I wanted my answer in cars. I want that left. That means I need birthdays to go away. So birthdays is going to go away. That leaves me with cars. And if you do this math correctly, that should be 3.875 cars. And I realized you couldn't have part of a car, so you'd have 3 whole cars and 0.875 on your way to the next one. So for this one, it tells you that you have, or asks you to find how many inches. So we are looking for inches. It gives you a number of 8 centimeters. And then it also gives us this ratio of 1 inch equals 2.54 centimeters. So I'm always going to start with my known, 8 centimeters. I want centimeters to go away, so I'm going to put it on the bottom. And then I am going to go to what I want, as long as it's possible, which is inches. I need a ratio that makes this true. So 1 inch equals 2.54 centimeters. And then it's time to do some math. So I multiply everything on top. 8 times 1 divided by 2.54. I'll make sure my units cancel out. So centimeters was on the top and on the bottom. And that leaves me with inches. Which is good because that's what I want my answer in. If you do that math correctly, you should get 3.15 inches. So I realize this is math that a lot of you could do on your own, but the whole purpose in this is so that we can convert. And as we go through chemistry, this math is going to get a lot more complicated because it's going to be things that you're not as familiar with. So that's why we're practicing it now. You'll notice this next problem has multiple steps. So that means our first ratio might not work, or probably isn't going to work. If you read the problem, it gives us some ratios up here at the top, and then it says how many birthdays would it take to own 2 cars. So our unknown here is going to be birthdays. That's what we're searching for. And our known value is the 2 cars. So I'm going to start with 2 cars in this box. I want to get rid of cars, so I got to put it on the bottom. And when I say bottom, it's actually diagonally. And then I am trying to get to birthdays. If you look at the ratios at the top, I have cars right here. I want to get to birthdays right here. There is no ratio that says cars equals birthdays, but there is a ratio that says cars equals money. So I'm probably going to have to convert to money first. So I'll do that in this next step. Then I'm going to go and get rid of money, and I want my answer in terms of birthdays. Okay. Then I get to go back and plug in ratios that make this true. So according to the problem, cars to birthdays, 1 car costs $800. So I played a matching game there. I put 800 next to money because that's how much 1 car costs. And then over here, $300 is how much you get for 1 birthday. You multiply everything on top, divide by everything on the bottom, and you make sure your units cancels out. So I have cars on the top and on the bottom. I have money on the top and on the bottom, and that is going to leave me with birthdays. And if you do that math correctly, 5.3 birthdays is how much you should have. The next one is very similar to this problem. It uses the same ratios that you use in number 3. So this problem gives you or tells you in 24 birthdays, so that's going to be a number we're going to need in the problem, how many cars would you have based on the ratios above? So how many cars is our unknown? That's what we're solving for. I am going to be starting this problem with 24 birthdays. Because I don't want that as my answer, it's going to go on the bottom diagonally. And if we look at our ratios, I have birthdays. I'm trying to get to cars, so that means I'm going to have to go through money. Since I don't want money as my answer, I'll put it diagonally on the bottom. And then I am trying to get to cars. Okay, now it's time to go back and plug in ratios that make this true. So, for every one birthday, I make $300. Or get $300. And then one car costs $800. And then you multiply everything on top, divide by everything on the bottom. Birthdays cancels out, money cancels out, and that leaves you with cars. And you would end up with 9 cars. Number 5 is solved in another video from your notes, and it's solved in another video on YouTube. So if you need help with number 5, you can go take a look at that. So I'm not going to do that one right now, but it is a good one to try. And then number 6 is more like the type of problem you're going to see in class. And that's because it doesn't give us any charts or anything like that. We're going to have to figure out how many steps it takes as we go. So, if I read the problem, the Richlands High School football team only needs 550 centimeters for a first down. Everybody knows that nobody talks about football in terms of centimeters, so we need to convert that to yards. So, the question is, how many yards is that? And my known is going to be this number right here, 550 centimeters. This other additional info is going to be part of our ratio that we're going to need in our problem. We always start with our known. So I'm going to set up a chart. I know it's going to take me at least one step, but I don't really know beyond that. So 550 centimeters. I need to get rid of centimeters, so I'm going to do that by putting it on the bottom. And then I'm going to ask myself, okay, do I know how to get from centimeters to yards? In a perfect world, the answer would be yes, but this isn't. So we are going to have to go from centimeters to inches. The first thing I'll do is go to inch. And since I didn't get to what I wanted, that means I'm going to need to extend this chart. I will get rid of inch. I'm trying to get to yards. If you know how many inches are in a yard, you could absolutely go to that next. If you don't, then the next logical place would be feet. And then we could get rid of feet and go to what we want our answer in, which is yards. So now I'm going to go back and plug in ratios that make this true. So right here, 1 inch equals 2.54 centimeters, so I play a matching game. 1 inch, 2.54 centimeters. And the next one, you need a ratio that makes it true. 1 foot has 12 inches in it. And then the last one, there are 3 feet in every 1 yard. You'll multiply all the numbers on the top, divide by all the numbers on the bottom. Be really careful in a problem like this one that you're using parentheses for those numbers on the bottom. And then we'll make sure our units canceled out. So I had centimeters on the top and on the bottom, inches on the top and the bottom, feet on the top and the bottom, and yards is what I am left with. And if you do your math correctly, you should get 6 yards.